As part of this course, we already worked with events. For example, the click event, which we listened to on buttons. Now, there are more events we can listen to, and events in general are an important thing in JavaScript, not just when working with JavaScript in the browser, but in JavaScript in general. Though in this module, again, I will focus on the browser-side JavaScript. You'll get an idea for how we listen to events in Node.js, for example, in the Node.js module later down in the course. And I will show you to which kind of events you can listen, which data you will get there and how to work with that data, and also how to control the behavior of events. We'll also finish this module by going back to our projects project, where we switched projects between these two lists, which we worked on in an earlier module, and we'll implement drag and drop there. So specifically in this module, we'll have a look at events, what they are, how they work, which data they yield to us. We'll then also, as I mentioned, have a look at how we can control their behavior, specifically how we can control what they do and how they propagate and what event propagation actually means. And as I also mentioned, we'll implement an example with drag and drop, which is a nice user interface pattern that you might need in many applications, and it is all powered by events which are built into the browser or which are exposed by the browser. So let's explore events in JavaScript. We already worked with some events, well, mostly with the click event, but we didn't do much with it. Now, the core idea behind events does not just exist in JavaScript, but pretty much in any programming language. Most programming languages have some kinds of events architecture built in, because the idea is that you can run code upon certain events. And that could be a user clicking a button, an upload finishing, a video playback starting or finishing or being paused. There are a lot of events you could think about that should trigger some code to run. We could also think about more abstract events that could happen on a server, like an incoming request or some scheduled task which should run every X hours and is triggered by some timer. So the exact implementation, of course, differs between programming languages, but also inside of JavaScript, it differs between the browser side and, for example, the server side with Node.js. On the browser side, we saw we can use add event listener to add an event listener to a DOM node. In Node.js, on the other hand, you often see on or once as methods you chain on some object, which then allow you to listen to certain events. Even with that different syntax, though, the general idea is the same. And the idea also is that events often or typically transport data. We haven't really utilized this yet in this course. We always worked without utilizing it. Now in this module, we'll have a look at which data is being transported. And you will get that data, an object that is created for each event automatically as an argument passed into the function you register as an event listener. And thus far, we always ignored that argument. We always ignored that object, but we actually do get it automatically. So in this module, we'll also learn how to use it and what's in this object. And that's, by the way, not just the case for browser-side JavaScript, for Node.js, or for any other programming language even. It's typically the same. An event typically comes with some data which describes the event, which might hold some metadata, which basically helps you interact with that event and run some code based on it. Now, as I mentioned in this module, I'll focus on the browser side, simply because that's easiest for us. We can immediately see something there. But the rough idea, the general idea of why we use events, that's of course always the same. And as I also already mentioned in the Node.js module, we'll also see how we would work with events there. So in the browser context, it's important to understand that we have different kinds of events we can listen to. A click on a button or a click on anything else. A right click or a double click, hovering over something or moving the mouse button away from something. These are all different kinds of events. And indeed, in JavaScript for the browser, therefore exposed by the browser into the JavaScript we run in it, as you learned, we have an event constructor function, a core event object, you could say, with some core functionalities which all events share. But then we also have specialized event constructor functions which are based on that core event, with the help of prototypes, as you learned, which hold additional information that only makes sense for certain events. For example, we have a mouse event which also might yield the coordinates of the event, so the coordinates of the mouse button when the event occurred. And in addition to that, it might also hold an event target, which describes the element in the DOM on which this event was triggered or which was responsible for this event. Now, event target actually is exposed by that core event object and shared amongst all events which are provided by the browser. Coordinates would be specific to the mouse event. The drag event, which we'll also see later, for example, could hold some extra data which we can attach to a drag and drop interaction, because such an interaction is a bit more complex and composed of multiple events, which kind of need to share information amongst each other, done with the help of some extra data that can be attached. And it also has an event target. And of course, you have way more events with way more data. They have certain things in common, like the event target and also a couple of other properties and methods, but then they also have their own special data that only makes sense for this kind of event. And in this module, we'll of course also explore a couple of these events. Now with that, before we dive deeper, let's get a feeling for some of the events we can work with and for the data they provide to us. As always, MDN is also a great place to go to. If you search for MDN event, and you click on that first search result, you can learn more about events, which is of course nice, but you can also find a detailed reference of the event object, for example, on this page here, and all the properties the event object has, all the methods it has as well. If you then scroll down to interfaces based on event, you will also find the more specialized events, like the mouse event I already talked about, or also the drag event. And a couple of other events which are in there as well. Some of those will be events you probably never work with or only rarely, and some of these will be event objects you work with quite regularly. Now you can always dive into these events to learn more about them, learn more about the relation between mouse event and event. As you see, there actually is another constructor function in between, another interface in between if you want to call it like this. And you learn about the specific properties and methods which, in this case, the mouse event has, for example. So MDN, as always, is a resource you definitely should also check out to learn more about events, learn all about available events. Here, for example, you'll learn about the different events that trigger such a mouse event, and to learn more about which properties exist there, if they are read-only, if you can change them, and so on. Now with that, however, let's go back to a project, and I prepared a basic project which you as always find attached. It's actually my snapshot of that project we worked on, where we can move projects between two boxes. But it's also this events HTML file, the events CSS file, and the events JS file. And these are the files we'll start working on. So make sure you double click on that events HTML file in the Windows Explorer or the Mac Finder to open that, because that will give us such a nice button and a couple of other elements which we can use to start diving into event objects and into events in JavaScript in general. So we get this nice button, and if we click it, it doesn't do anything because I haven't added any event listeners. Now, you learned how you can add an event listener to a button. You first of all select the button, for example with query selector or with getElementById, and then you can use the add event listener method, which exists on any DOM node basically, to attach an event to it. Now that is always something you can do, but before we do it like this, let me also show you two other ways of adding events. One is a way that is pretty old and which you shouldn't use anymore. Still, for completeness sake, I want to show it to you. You can go right to the HTML node in your HTML code, and on there you can add an attribute on click. And this is not an arbitrary name chosen by me. There are various on attributes for different events this element supports. So for a button, we got a lot of those: on blur, on click, on double click, on context menu, which is a right click, on drag, various drag events, which I'll dive into later, and so on. There are a lot of events we can use there. Now, I'm interested in on click here, and then as a value, you assign some JavaScript code which should execute when this event here happens. So for example, here we could throw an alert and say, hello there. And this would be valid JavaScript code. Here, you could also execute a function which is defined in your events.js file if you wanted to, or just write some inline JavaScript code as I'm doing it here. And with that, if you then reload this page and you click here, you see this alert. Now, it's strongly discouraged that you use this approach. It makes your project very hard to maintain. It's completely unexpected that we suddenly find JavaScript code in our HTML code, especially when we have separate JavaScript files, and it just makes working on your project, especially on bigger projects, much, much harder. So don't mix HTML and HTML attributes and JavaScript code. It's absolutely not a recommended practice. We should register events in our JavaScript file instead. So here in the events.js file, which is getting imported here in the events HTML file, we can get started by selecting our button, for example, with document query selector button, like this. Now we have access to the first button we find, which in this case is the only button I have on the page. And now instead of add event listener, which you of course can use and which you actually should use, we also have another way of adding an event. It's pretty close to what we did here in HTML, just this time in JavaScript. We can set a value to the onClick property. So this onClick attribute, which I used a second ago, basically has a property equivalent. And we can set this equal to some code that should be executed when this event occurs. Now, this always should be set equal to a function, can be an anonymous function, like in this case here, could also be pointing at a named function. And then this function will execute when the event occurs. So either like this, as I said, an anonymous function, or we define a named function with either function definition way you want, so either with the declaration or the expression approach, with the function keyword, or as an arrow function. Here I'll go for an arrow function. And then here we could name this on button click or button click handler. Both are common naming conventions for naming functions that are triggered upon events, either on, click, or something like that, or with this handler naming here. And then here, I define my function that should be executed. Button was clicked is an alert text I want to display in that case. And then here we can go to button on click, and point at the button click handler. Don't execute it right away. Instead, as with the event listener, point at it like this. If you do that, and you now reload, we'll again see that alert. Now, this is better than using an attribute in our HTML code, because at least now it's in the JavaScript code. And actually, this is fine to use, especially in smaller projects, but it has one major downside. We can only add one handler for this kind of event to this element. So if you want to, for example, run two different functions upon a click, let's say we have another function, another button click handler, and here I want to console log this was clicked. Now if I want to add both functions on this button, we can't do button on click like this twice. Well, we can, but you'll see that now the first function will never run. So if I now click, I only see the console output here, but I don't see the alert. And the reason for that is that I simply overwrite the value which is stored in this property. So this is not added or appended as a listener, it's simply overwriting the old listener. Now, of course, the workaround could be to create a third function which calls these two functions, but that quickly gets cumbersome because then you have no fine-grained control over when you want to use which handler. Maybe you want to remove a handler at a later point of time. That's all pretty tricky. So you can use this approach, but it's also not recommended. Instead, it is recommended that you use add event listener, as we did it throughout this course, because this allows you to add multiple event listeners to the same element, and you also have a remove event listener function or method which you can use to, well, remove an event listener, which also can be very powerful in more complex apps where you might have certain scenarios where under certain circumstances you want to remove a listener from an element and then maybe re-add it later. That's super easy to do with add event listener and remove event listener. So let's add an event listener here. And this method, as you already learned, works such that as a first argument, you have a string with the event name, and that's now basically the same name as we had here on the property, but without the on at the beginning. So here we do have click, and we also do have DBL click for double click, or a context menu for a right click. And you see, I'm getting auto-completion here, and you should be getting this as well if I open my quotes here. And here I'm interested in a click. Then the second argument is the function that should be executed when this click occurs. And there I want to point at my, and for this I'll bring back these two functions, I'll point at my button click handler here. Now, again, you just point at it like this. Don't execute it, just point at it like this. And with that, we set up an event listener. Now if we reload, and I click the button, we again get this alert, but now with the most elegant way of doing this. And now, as I said, we can also remove this if we wanted to. So here, let's say after, with set timeout, after 2 seconds, second argument defines the duration, I want to execute this function, and in this function I want to remove an event listener. So basically after 2 seconds, this event listener should be removed. And now you do remove an event listener by specifying the event for which you wanted to remove an event listener, click, and then as a second argument, the function which you registered as an event listener. And here it's super important that it's the exact same function object. I'll dive into a couple of pitfalls you could face with remove event listener in a second. This, however, should work, and therefore now if you save that, you will see that if you reload and I click this right away, it works, but if we wait for 2 seconds, now nothing happens because we now removed the event listener. And that's a super powerful feature of add event listener, that you can get rid of the event listeners. So not only could you register more than one, you can also remove them if you need to. Now, as I mentioned, remove event listener also has a couple of pitfalls which you can easily overlook, or which you could not be aware of, especially if you're new to JavaScript. Because as I mentioned, you remove an event listener, not with some ID which would be returned by add event listener, which you then could pass to remove event listener, but by basically specifying the exact same listening setup as you have here for add event listener. So same event name, same function. The event name, that's of course simple, but the same function, that can be tricky. It works here, but you could think that it also works if you pass an anonymous function here. So here, anonymous function, console log, clicked. Now we could grab this function here and also use it here, right? It's the same function, it does the exact same thing, right? However, if I save this and I reload here, you'll see I can click this and I can click it forever. So this never seems to be removed, right? The 2 seconds passed and it still is clickable. The reason for that simply is that this here looks similar to us humans, but technically it's not the same function object. This creates a new function object, and so does this. So these are two totally different objects, and as you learned in the reference value lectures, if we would compare these two functions here with, let's say, an equal sign, if this would be possible, then this simply would not work because these are two totally different objects. So this does not work. Instead, we have to make sure we store that function in a constant, which then holds the address of this function object. And we then here, when we use this approach, only use that same address and therefore the same function. So now this works. A similar pitfall is if you bind this. So if you bind this to bind this keyword in the function or to pass in some arguments when this executes, something we also did throughout this course. Now you might again think, well, this is similar. No, it isn't. This is not similar. Bind creates a new function object, and therefore here we create a new function object, and here we create a new function object. So this also will not work. If you want to bind this or any arguments that should be passed in, and then eventually remove this later, you will have to store the bound function in a new constant like this, so that again we have the address of this function object stored in here, and then use this here, so that again we use the same function object. So this would work, the other approach would not work. So if you now reload this, You see, I can click this initially, but if you wait for 2 seconds, now nothing happens. So that's add event listener and remove event listener, and some pitfalls you can face there, which you just have to be aware of so that you can work around them. So now that we know how to add events or how to listen to events and how to remove event listeners, which can also be quite handy, let's have a look at that event object, which is generated automatically by the browser in this case and passed into our event handler, and which in general though, even if you're not working in the browser, is a core idea behind event-driven code. Whatever causes an event typically also provides you some data along with such an event to describe it, to give you some extra metadata, or to give you methods to control how the event behaves thereafter. Important for some more complex events, for example. So therefore here on the button click handler, instead of just showing an alert, let's accept the argument. You can name this argument however you want. Often it's named event or EV or just E because it is describing the event we're getting. But since it's your function, you can name this however you want, of course. And then here I want to console log that event object. It will be an object so that we can look into it. So now when we click our button, this will be logged. For now, by the way, I will also change this back here to directly point at the button click handler down there. So if we save that and we then reload and click on this button, we see we get a mouse event here, and we see it has a bunch of properties, and it actually also has a bunch of methods, which we just don't see here when it's output like this. Now we have a bunch of properties, which in the end describe the event. This, for example, tells us if the Alt key was pressed whilst we clicked. And that can be interesting for building certain user interfaces where you maybe want to do something else if the Alt key was pressed while the user clicked somewhere versus when it was not clicked. You'll have similar properties for the Control key, for example. We see which button was pressed. 0 is the left button. If I right click this, by the way, nothing happens because I haven't registered this. Only a left click works, and you'll have to reload to click again because we still removed this here, right? So back to the event here then, we see which button was used, left button. We then also have client X and client Y, and that would be the exact coordinates of where my pointer was, so the mouse cursor was when I clicked. You can see if I reload and I click again somewhere else, these are different coordinates than before. And so on. Now in general, check out the MDN documentation to get detailed explanations of all properties and what they do, and of course also simply play around with that to learn more. As you see, for a mouse event you get various coordinates. Here, these are the general coordinates inside of the window. Here, for example, we would have the coordinates inside of the button itself. So if I reload and click on the top left, for example, you see that would be pretty small because coordinate system starts on the top left and I clicked very close on the top left, and therefore I get these very small coordinates. Now if we scroll down further, we see one very important property, and that's the target property. Every event has this, and this describes which target, which element in the end caused this event. So where, in this case, where you clicked on. So target in this case gives us access to the button DOM element, and this can be super useful, of course, because if you have a scenario where you want to interact with the DOM element on which you clicked, well then it's super convenient to have this target property, which in the end gives you direct access to this element. Here's an example. If we go back to events HTML and we duplicate this button here real quick, click me 2, and we then alter our events.js file to register listeners on all these buttons and maybe not remove it anymore, so that here we don't select just a button, but we use query selector all to select all buttons. So I renamed this now. And then down here we can't use button add event listener anymore because we don't have a single button anymore. But instead we can go to buttons and then use for each to get access to each button we selected in this anonymous function I passed to for each. And then in here we can add our event listeners and register click events on the button click handler. And now, as you see, if you reload, you can click either of the buttons to trigger that event. Now let's say we want to disable the button on which we clicked. Well, then it would be pretty hard to do this without knowing on which button exactly we clicked. We would probably have to create two different methods or functions which we assign as listeners, which would be pretty cumbersome. Well, with event target, we can just say event.target.disabled equals true. Buttons have a disabled property which you can set to true to, well, disable them. Now let's also console log the event object still, however, so that we also get some output that proves that we clicked this. And let's then reload, and as you see, if I click this now, I get this output, but if I click it a second time, I don't get it because actually the button was disabled. Now I haven't set up styles that would reflect this, but if we inspect this element here, we also see it has the disabled attribute. And if you click on the other button, you see that button gets this attribute as well. So this is very useful. Event target gives us direct access to the direct element we clicked on. Of course, we have more than just click events though. Back on our buttons, we can also register other events, for example, mouse enter. Mouse enter is triggered whenever our mouse or cursor enters this button, so if it is moved above this button. Now let me disable this disabling code so that we don't disable the button anymore. And now let's have a look at that. If we now reload and I move my cursor above this button, you see that event triggers. If I keep the button on it, if I keep the cursor on the button, nothing happens. If I leave the button and re-enter it, we again trigger this. So of course you can also add a listener to listen for when the mouse leaves this button and so on. Now please also note that if we now inspect this, we got a lot of properties which we knew before too, client X and so on, so these coordinates. What we also have now, however, is a related target. That's quite interesting. We have this property for mouse enter, mouse leave, and so on. This tells us which element the cursor was on before the mouse enter event triggered. So from which element we're coming basically. And that in this case was this div which surrounds the buttons. So that's quite handy. Also good to know there, if you are very fast with your cursor and you move your button very fast, your cursor, you see in this case related target actually is the whole HTML document and not the div, because I moved my cursor so fast over the div into the button that the browser basically didn't get that the cursor was on the div in between as well, because the browser does not check the cursor position multiple times per millisecond, but, well, quite often, but still only periodically. And therefore, if you move your cursor in a very fast way, this will not always be the direct neighbor of the button in this case that triggered the event. So that's just good to know. Nonetheless, it's a useful property which can help you understand where the mouse cursor is coming from. Now, of course, we have way more events, and as I mentioned, MDN is the place to go to learn more about them, and in general, simply throw some elements onto the screen, register some listeners, and play around with events there. That's the best way of diving into them on your own and learning more about them. It's really what I would recommend for learning more about events, event objects, and which events you have. Of course, you're also not limited to registering events only on buttons. You can register events on basically any DOM element, on any HTML element you want to listen to, whatever you want to listen. You can also register events on the overall window. For example, you can listen to scroll events there. Now to demonstrate this, let's go to events HTML, and now below this div here, I'll add a section, give it an ID of long one, however you want to call it, and in events CSS, I'll just add a selector, long one, ID selector, and give this a height of 3000 pixels, so that this simply is a big invisible section. If we now reload, we can scroll this page, right? Nothing happens there, nothing is down there, but we can scroll because we have the large section down there. So now that the page is scrollable, let me show you how you can listen to scroll events. For that, in events.js, here at the bottom maybe, we can go to our window, and there we can also add an event listener. And here we also have the scroll event to which we can listen. Now there we can also, of course, output the event object which we're getting, and therefore let's have a look at what we get there, what's inside this event object. If I reload now and I scroll, you see, well, obviously a lot of events are fired, basically for every scrolling action we do. Again, there of course is some delay or some interval at which the browser checks for this scroll event, but as you see, it fires a lot. And therefore, this, by the way, is also an event you should be careful with, and you shouldn't listen to it too often or do very complex things when it occurs, because indeed, well, as you see, it fires a lot, and if you do some heavy calculation whenever this event occurs, you might slow down your page. Now, what's inside of that event, though? Well, we see it's a rather short event object, has a couple of properties here. It does have a target, which is the entire document, so maybe not useful. And therefore, this is an event object where we might not get too much out of it. Still, we can do very nice things with it. For example, we could calculate how far the user is away from the bottom so that we can add more content to the bottom if the user is close to the bottom. This provides such an infinite scroll feeling, which you might know from other websites. Now, after this lecture, you find a text lecture with a short example snippet for such a dummy infinite scroll implementation you could use. It's just one idea of what you could do with the scroll event. Just want to put it out there that it exists and that you should also be careful with it, especially regarding the heaviness of calculation you perform based on it. Now that we have a rough understanding of what events are and that we can listen to a broad variety of events on different elements, you might be wondering, how do you know which events exist on which element? For example, we have the scroll event here, which we can listen to on the window. Can we also listen to that on a button though? Well, if I enter quotes here, single quotes, I can type scroll here. So my IDE suggests that we can listen to that on a button as well. And indeed, we can listen to scroll events on pretty much all DOM nodes because we can always put content into other HTML elements, and then this content might be scrollable. And yes, even though it might not make much sense, we can also configure and style a button such that it holds scrollable content. So we can listen to scroll events on basically all DOM elements. And that's pretty much true for pretty much all events. Almost all DOM elements support all events. But as always, MDN is the place to go if you want to be really sure. You can, for example, search for MDN button to find the page for the button element and learn more about it. And there, if you scroll down, you find the DOM interface that belongs to it, the HTML button element. And there you find its specific properties. What you don't find on this page here is any section about its specific events. So we seem to be on the wrong page. So the next step is to go to the next element or the next constructor function, next prototype, if you want to call it like this, that is implemented by the button element, which is the HTML element. And there we now also find these on event listeners here. And this gives you an idea of which events you can listen to on any element which is based on HTML element. And that's a lot, as you can tell. And this is how you can find out if a specific element supports a specific event. Now, typically, you will rarely look this up because you, A, always work with the same kind of events anyways, and B, well, whatever makes sense to you logically typically is also supported by the browser. For example, that you can click on pretty much any DOM element makes a lot of sense because the user can click anywhere on the page, so you can also listen to that. So typically, just thinking about this logically already allows you to find out which events are supported where. If you can scroll something, you can listen to a scroll event. If you can click something, you can listen to a click event. So let me comment out these two event listeners here, or these two examples, and let's dive into another kind of event we can listen to. For this, I'll add a form element here below my div with the buttons. And in there, I'll add a label for title, which says title, and an input type text with ID title, let's say. Very simple form here. Action can be left empty. And with that, all we need to add to finish this form is a button of type submit. That's now important that you set this type, where we, for example, say submit as a caption. If you now save this and you reload, you'll get this form? Well, the button is pretty big because it gets the same styling as up there, but for this example, it doesn't really matter. We have this form here, we can enter something here, and I can press submit. And now watch closely what happens if I do press submit here. You see, the page reloaded, which reset my zoom in this case. Now it reloaded because the default behavior for the form element in HTML combined with a submit button is to send this form data to your server. So to the server which serves this page. In this case, we have no web server. We serve this through the file protocol, but still it tries to send this to, you could say, to the source which served this HTML file. And this can make sense depending on which kind of application you're building, because eventually you want to get that user input to that server so that there you can work with it, store it in a database, do anything like that. Often, however, when you use HTML, you also want to prevent this from happening. You don't want to send that data to the server always when this button is pressed. Instead, you want to step in with JavaScript and maybe validate the user input before you then take it and send it with the help of JavaScript. Something we'll also dive in a separate module, how to send HTTP requests from inside JavaScript. So you might want to prevent the default behavior of the browser, which for a submit button in a form is to submit that form. And here again, JavaScript and the browser got you covered. So let's say we want to listen to that form submission. For that in events.js, we can select our form, maybe down there, with document, query selector, form. I only got one form tag in there, so this will select that first and only form. And then on that form, not on the button as you see, but on the form, we can add an event listener, and there's a special submit event, which the browser exposes on form elements. And that is one of the rare events which does not exist on all DOM nodes because only form elements can be submitted. Only form elements have that submit event. Again, MDN also tells you that. So here we can listen to that submit event and then execute some function when it occurs. In this function, of course, again, we get an event object and we can console log that. Now, as a default, you will see that if I try to execute this and I reload this page, if I click submit here, we briefly saw that being logged, but since we sent that to the server automatically and that server, or the file protocol in this case, therefore reloaded the page, we lost our output there because, well, the page reloaded. And now we can do something which we haven't done before. This event object does not just give us a couple of properties, it also gives us methods to control this event. And there we got a method which you can call right at the start, for example, which is prevent default. This exists on any event object in JavaScript, not just for the submit event. And it does what the name implies. It prevents the default behavior the browser would apply for this event otherwise. Now, the default behavior, of course, depends on the kind of event. For the submit event on a form, the default behavior is to submit that form to a server. For a link, for example, the default behavior would be to go to that link. And you can always block the browser from doing that and from following its default behavior, and then instead implement your own logic. So now with this added, you will see that if we now reload again and I click submit, now we don't lose this because now the page doesn't reload, because now this default of taking the form data and sending it to a server and hence reloading the page, that is now prevented. Of course, this means now you will need to implement it on your own. And as I mentioned, we'll have a whole module where I show you how to send HTTP requests on your own from JavaScript. But it's a powerful feature to be aware of because you'll often need to build exactly the user experience you want, where you sometimes, especially when working with forms, want to avoid that default behavior and want to override it. So prevent default is a very important method on the event object, which you can use to control what the browser does with that event. We also got another important method for which we first of all need to understand how exactly event behaves. Our events in JavaScript, in browser-side JavaScript, have two phases through which they run essentially, and where they then trigger your event listeners, a bubbling and a capturing phase. let's say we have a button in a div which is in a section. This could be some markup we have. Now we click that button here. Now what actually happens is that the browser runs through two phases where it checks for listeners to that event. First, it runs through a phase which is called the capturing phase. Second, it runs through a phase which is called the bubbling phase. Now, the capturing phase goes from outside to inside. Now, what does this mean? It's important to understand that a click event on such a nested button here can not just be listened to with event listeners on the button, but for example, also with an event listener on that section. And the browser during the capturing phase checks if you got a capturing event listener on, let's say, the section registered, which would then actually run its function before any event listeners registered on the button, because it's from outside to inside of the capturing phase, and the section is outside of the button. The bubbling phase, on the other hand, does the opposite. It goes from inside to outside. Now, all event listeners you add with add event listener are by default registered in that bubbling phase, which means if we have an event listener on the button and on the section, the button event listener will run first, the section event listener will run second. We can change this, and we can also do interesting things with that bubbling and capturing behavior, as I will show you in the next lectures. Let's first of all make sure we fully understand what's happening. And for this, I'll again use my buttons, however, just the first button here which I find with query selector. And then I can add an event listener to it as we did before. So button add event listener to a click again, and then maybe execute this anonymous function where we get the event object and where we then console log the event object. Now I'll not just do it here on the button, however, I'll also get access to this div here, the only div I have on the entire screen. So therefore here I'll get my div with document query selector for that div tag, and also add an event listener on that. And it doesn't matter if you register that event listener before or after the button event listener. So here I will also log my event object. And now for us to be able to differentiate them, here I'll also log clicked div. And then I'll copy that, and down there we can log clicked button. Okay, now with that set up, if I reload and I click on the button here, you see both execute, button and then div. So it executes from inside to outside because, as I mentioned, by default, all event listeners are registered in the bubbling phase, which means that capturing phase, which runs first, is totally ignored, but thereafter, when the browser checks from inside to outside for that element on which the event occurred, it first finds that on the element itself we had a listener, therefore this runs first, but then it checks if there was a listener on the surrounding element, which in this case is the div, and there we also had a listener, so it executes that as well. Then the browser, by the way, also goes on to the body and checks if there we had a click listener, but we don't, so therefore it doesn't execute any code for that because, well, there is no code to execute. But it goes from the element from which the element occurs to all its ancestors and checks for event listeners on them. And if they are there, it executes them. This is what the browser does. Now we could switch to the capturing phase by adding an extra third argument on the event listeners. So here on the div, for example, we could add a third parameter, and if we set this to true, the default is false and therefore doesn't need to be added. But if we set this to true, we're telling the browser this event listener should be part of the capturing phase. Now we don't have to switch all event listeners to the capturing phase. We can just add this one here. And now you will see that it will actually run before this button event listener here runs. So if I reload now and click this button, you see the div was clicked first, or the event listener ran first, and then the button, because this listener here triggered in the capturing phase, which comes before the bubbling phase. And since we, well, registered this listener for the capturing phase, it executed its code. So this can be useful if you want to switch the order and you have event listeners on the element itself, but also on some ancestor. And for whatever reason, you want to execute the ancestor listener first. That can be done by passing that extra third argument. Here I'll remove it because I don't want the behavior here, but it is something you could do. Now, this entire process of having multiple listeners for the same event, because the event does not just trigger on the element itself, but also on ancestors, that's called propagation. It means that the event propagates up, it bubbles up, or in the capture phase, it kind of goes from outside to inside, but it basically means the event does not just occur on the element itself, but also on all ancestors, or at least we can listen on all ancestors. It occurred on this button, but it's listenable on all ancestors because it propagates up. It bubbles up. It can be used anywhere above. Now you can prevent this, however. Let's say we do have an event listener on the div here, but we really only want to react to clicks on the div here, not to clicks on a button in the div. That could be a requirement you have in an app, where you really want to make sure that the button clicks don't trigger the div click listener. To make sure that the click event for the button, for example, doesn't propagate anymore, you can call event.stopPropagation. That's not the same as prevent default. Prevent default stops the default behavior the browser might perform upon such an event. For a click event on a button, we have no default behavior. For a click event on a link, for example, we would have one. There, the browser would leave the page and go to that link's destination. Stop propagation does nothing with the default behavior. The default behavior still executes. So for a form, for example, the form would still be submitted. But it stops the propagation, which means any other listeners for the same type of event on some ancestor elements will not trigger their event listeners for this event. So now you will see that clicked div will not be printed to the console when we click on a button. So if I reload and I click on a button, we only see the clicked button event listener. I have to click somewhere else on the div to trigger that div click listener. So that's what stop propagation does. You also have stop immediate propagation. That is useful if you have multiple event listeners on the same element. So if we had more event listeners on the button, then after the first event listener, the other button listeners, so the other listeners on the same element, also wouldn't run anymore. With just stop propagation, all button event listeners would execute and only ancestor element click listeners would not execute. That's the difference here. And just as prevent default, this can be a very useful tool to make sure that you can handle the events in exactly the way you want. So you learned about stop propagation. It's important to understand that not all events propagate. Again, common sense is a good starting point to find out whether an event propagates or not. For a click, it makes more sense. When we click something, we could also want to listen to a click on a parent element. For hovering over something, it makes less sense. If I add mouse enter here to my button and also to my div, and I reload, you see now I entered the div. So yeah, I'm still printing clicked div, but it happens because of me hovering over it. Now I hover over the button, and therefore you see indeed I only trigger clicked button and not the div as well. That first output here was from when we reached the div for the first time. So mouse enter, mouse move events typically don't propagate. If you're not sure whether they propagate or not, whether they bubble up, you can always just print the event object and have a look at it, because you'll find a bubbles property in there, and as you see it says false here, which means this does not bubble up, and hence you don't have to call stop propagation because it won't propagate anyways. And there are a couple of events, drag events for example, for drag and drop, which don't propagate up because that typically would lead to undesired behavior. With event propagation, you can do quite interesting things. Specifically, you can implement a pattern, which is also called event delegation. Let me show you an example. Let's say in events.html, so in our little demo file here, we have an unordered list here, or any kind of list data. That's where this pattern typically shines, with a couple of list elements in there. Item 1, and then we also have more items, 2, 3, 4, and 5. Now I'll quickly add some styles so that we can have some output there, or that we see this at least a bit. And I'll style each list item to simply have a padding of 1 rem and to have a border of 1 pixel solid and then some border color here. And the unordered list will get a list style of none to remove the bullet points. So some basic styling you can add to event CSS, and then this basic list here, which I added to my HTML file. Now, if we reload this, we see this list down there. Now, we want to be able to click on these items and color the clicked item red. Let's say that's our goal here. If it is red already, we want to remove the color. Well, for that, let's go to events.js, and now, of course, we got 2 possible approaches. One is that we select all list items and we add multiple listeners. So we could get all list items here with document query selector all, select all LIs, and then use list items for each, for example, to go through them, or use a for-off loop, of course. And then on each list item, we can add an event listener for the click event, and then have a function in there where we get the event object. And then in here, we can say event target, and then let's say class list, because event target is a DOM element. So we have the class list property available, even though my IDE doesn't know it. And then here we simply toggle the highlight class, let's say. And now we just have to add this highlight class to events CSS, like this. And there, let's say we have a background color of red and a text color of white then. So this is something we can do, define this highlight class, register multiple click listeners on all the elements, and now if we save and reload, we should be able to click them and toggle our colors here. Now that is working. However, this approach has a couple of disadvantages. For one, it's pretty cumbersome to add multiple listeners like this. Additionally, it can get bad from a performance and memory perspective because we got a lot of event listeners out there. So let's have a look at the alternative, which uses this delegate pattern, this delegate approach. There, instead of adding multiple listeners on each list item, we take advantage of event propagation, of the event bubbling up. And therefore we get access to the entire list with document query selector UL, so with the list that holds the list items. Now we can register an event listener on that list. So I listen to a click event on the entire list, because since events bubble up, we can also listen to a click on the list when we actually clicked on a list item, because that's how JavaScript events behave, most events at least. So here I can now copy this logic here, this function, copy it in here, because I still want to use the event target and toggle highlight. And that's now, by the way, also the advantage of event target. Even if my listener is registered on the list, event target will refer to the actual target on which we clicked, which in this example is our list item. So now if I save that and I reload, I got the same behavior as before, but now with only one event listener instead of multiple event listeners, because we're taking advantage of event propagation, and then we're adding a listener on the next higher element, which in this case is the list, instead of every child element itself. This is the event delegation pattern. Now, this event delegation pattern can become problematic if we have a more complex structure. Let's say here for our list items, they're not simple like this. Instead, inside of li, we got a h2 tag, which wraps our item 1 text here. And then next to that, or below it, we also got a paragraph with some text. Now let's say we have a couple of those items here. So I'll just quickly copy and paste them and change the numbers here so that we can differentiate them. And auto format. And now if we reload, we have a problem. If I click on the title, now you see this gets the red background, not the entire element. If I click somewhere else, the entire element might get this, or just a paragraph. So now, because we're referring to event target, we have a problem. We have a problem because event target is the actual DOM element on which we clicked, and that's the lowest possible element. So that's either our h2 tag, or if we clicked outside of h2 and outside of paragraph, it's the entire list item, or it's just a paragraph, or whatever else we might have in there. So just coloring or using event target is not helping us here. Now we also do have another property available, and that is event.currentTarget. This is different from event target. Let's see if that helps us. If we reload and I click somewhere on the h2 tag, well, event current target is the entire unordered list here, because current target, unlike target, is not the actual element on which you clicked, but the element on which you added the listener. So current target here always refers to the list element, because that's where we register our listener. So that can also be useful sometimes, but here it isn't. It's still not the element on which we clicked. It's still not the list item. It's just a list, which also is not what we need. Well, we can use a combination of event target and DOM traversal, which I covered earlier in the course in the DOM module, to get access to the list item. What do we know about event target? Well, we know it's inside of our list, and if we have a look at our list, we see it's definitely somewhere inside of the list item, right? Because we have just a list and the list items. So we know it's inside of our list item. Hence, it's either the h2 tag, the paragraph, or the list item itself. Now you learned about a specific method that can help us here. And that would be on event target, which is some DOM object inside of our list, the closest method. Closest exists on all DOM objects, and it traverses up in the ancestor tree. And there you can select the closest element with a certain CSS selector. You could select by ID, by class, or just by tag. And in this case, I'm looking for the closest LI. The cool thing is, closest does include this element on which you call it itself. So if we clicked on the list item itself, this will give us the list item itself. If we clicked on some h2 tag inside of the list item, this will give us the closest li ancestor, which is this list item. So it always gives us the closest list item, which is exactly what we need here. And therefore here, we can now call class list toggle on the closest list item. And now this will work, because now no matter where we click, you see, I always select the entire list item and color the entire list item. So this is now the perfect event delegation pattern, because now we delegate our event and we still make sure we work with the right element, with a combination of event target and DOM traversal. With that, we learned a lot about events, how to listen to them, how to work with the event object, what we can get out of the event object, and also about this event delegation pattern. Now, sometimes you don't want to listen to an event, or at least not just listen to an event. You also might want to trigger an event programmatically. I'll show you an example for when you could do that a little bit later in this module in our project application. Let's for now just see how it would work. Let's say when I click any list item, for whatever reason, I also want to trigger a click event on my button. So first of all here, I'll again listen to a click event so that I can see that it worked. But now back to the list item. From inside this event listener, I want to trigger this event listener. Now, of course, we could store this function in a named function and then just call this function from inside here. But let's say for whatever reason, that's not really an option. We really want to click that. A better example might be with our form, by the way. There we could say we want to submit the form, not just with the submit button in there, but also when something else happens on the page. That's probably a better example because it's a bit more realistic. So let's say when we click any list item, for whatever reason, we want to submit this form. Now, to do that, we need access to that form element. So we need access to the element for which we want to trigger an event. And then here, in this case, on a list item, or when the list is clicked, or any item in the list, I want to call form. And now you can call click there, for example, to simulate a mouse click on it, or also submit as a method, just like that. And this does not just exist for the form, but basically for any DOM element. a lot of the events you can listen to can also be triggered programmatically, especially something like clicks or form submissions. So now with that, if you save this and you reload, you will see that if I click any list item here, the page reloaded because the form was submitted. Now you might be wondering why our event listener here for the form submission is not doing its work and preventing the default. Now if you trigger a submit event programmatically, then indeed the submit event listener is skipped. Typically event listeners execute. If I, for example, instead of submitting the form, simulate a click on my button, and please note that I do have a click listener on the button, you will see that if I do that and I reload, this click listener does execute, though with a dummy mouse event where all coordinates are 0, by the way. For form submission, the event listener is not triggered. So triggering such an event programmatically is not exactly the same as when a user clicks on it. It can bypass certain listeners like a form submission listener. Still, from time to time it can be useful, and it is good to be aware of it. Now, if you still wanted to work around that, by the way, you could of course select the submit button here in the form, and instead of calling submit on the entire form, you call click on the submit button. Then it will basically do the same as if a user clicked the submit button, which will trigger the submit event listener and allow you to prevent the default. So that would be possible. So even if you need to submit the form, you can still trigger that programmatically by simulating or by triggering a click on the button instead of the form submission itself. Now to finish this up, before we dive into our practice project here, one note about the this keyword. We already saw earlier in the course that inside of event listener functions, this is actually bound to something else, to the event source, as I mentioned. And therefore in the past we had to use bind or arrow functions to make sure that this actually points at the right thing. Now let's quickly see this in action again. On this button here, where I added an event listener, let's not just console log event, but also console log this here and see what we get. Now please note that here I'm using an arrow function though. So now if I reload and I click this click me button, you see I get the window object there. Because as I said, I'm using an arrow function and that ignores any bindings you might have assigned to this when this function gets called. And here the thing calling the function is the browser. The browser does bind this to something else though. And to see this, let's convert this here into a regular function, so to say, without the arrow, but with the function keyword and still with the event object, of course. And let's see what this points at right now with a normal function being used here. If we now reload this and click on that button, now you see this points at the button here. So in the end, this points at the event target. To be precise, as I can show you here on our list event listener here, if we console log this down there and transform this to a regular function as well, and not an arrow function. So to be precise, as you see if you click down there, it points at the current target. So not at the concrete target you clicked on, but at the current target. So basically at the element on which you registered the event listener. That's what the this keyword refers to inside of a function you add as an event handler function, so you assign to event listener if you don't override it yourselves by binding this function to something else and binding the this inside of the function to something else therefore, or by using an arrow function as you saw. This is how you can kind of override or change this behavior. By default with a normal function, this inside of a function which you assign to an event listener points at the current target of this event. So now that we gained some experience with events and saw a lot of examples and how to work with events in JavaScript, specifically in the browser, let's have a look at drag and drop and how we can implement such a behavior in a web page. Now we'll do this on this project example we already worked on in the past, but before we dive into that, let's go through the steps that you need to go through to make elements draggable on your web page, and then also to make sure that they can be dropped somewhere and that something happens if they are dropped somewhere. So to make elements draggable, you have to mark them as such. And you do that by adding the draggable attribute or setting the draggable property on DOM elements to true. So both needs to be set to true, either the attribute or directly through the property. Once you did that, this element is draggable. The next step then is to listen to a drag start event on the element which is draggable. This will be triggered whenever a user starts dragging the event. In the event listener there, you can also interact with the event object to describe the drag operation if you're copying or if you're moving, which will, for example, also affect how this is displayed to the user, how the cursor changes and so on. And you can also append data to the event. Because a drag and drop operation is actually a combination of different events on different elements on your page. And in order to make sure that they can work together and that you know in the place where you drop something what you started to drag in another place, you can add data to that drag event, which is then invisibly kind of passed around to the other events related to dragging and dropping. So once we started our drag operation and we configured the drag event, we have to tell JavaScript where the item can be dropped. Of course, the user can drop the item anywhere, but we typically don't support it everywhere on our page. Instead, we kind of mark the areas where an item can be dropped by adding an event listener to the element on which the other element can be dropped. We add a listener to the drag enter and the drag over events. You can omit the drag enter event, you definitely need the drag over event. Both will be triggered whenever an item is dragged onto that element. The difference between the two elements is that drag over basically also triggers for child elements of the element where you added it. Drag enter won't trigger there. And then here the trick is that in the event listeners you set to these events here, you have to call prevent default, because the default is always that a drop operation is cancelled, so that drag and drop isn't allowed onto an element. Because as I said, for most parts of your page you don't want to allow it, and therefore that's the browser default. You have to prevent that default to allow a drop operation. So it's an important step to listen to these events and prevent the default to allow a drop. Now, before we react to a drop, you can also optionally listen to a drag leave event if you want to update the UI, for example, update some styles when the item is dragged away from the element on which it was dragged over. That is optional. Not optional, at least if you want to do something upon a drop, is that you listen to the drop event on the same element where you listened to drag enter and drag over. The drop event will only be triggered if you prevented the default in drag enter and drag over and the item is then dropped onto that same element. Now in that drop event you can then do whatever you want to do upon a drop. Update some data, update the UI, move the element on the UI, anything like that. Because that's also important. When you make an element draggable, you'll get some visual feedback that looks like the user is really dragging the element, but it's actually not getting moved in the DOM technically. You have to do that programmatically through JavaScript if you want to update the DOM after performing such a drag and drop operation. You also optionally can then listen to a drag end event, not on the place where it was dropped, but on the dragged element itself. And there you could also then update the UI or some data, whatever you want to do. The drag end event is always fired, even if the drop is cancelled. So if the element was dropped in an invalid area. But as I will show you, you'll get some property on the event object, which tells you whether the drop was successful or not. So that's the theory. Let's now go through these steps and implement drag and drop step by step in our project. For that, I am back in the project we worked on earlier. We'll use the index.html now and the app.js file. And here in the browser, I'll therefore go to index.html here instead of events.html. This is the project we worked on where we can move items between our two boxes here, just like that. And well, this is where I now want to implement drag and drop. Now, as I said, it all starts, and actually I'll disable this analytics thing here. It's a bit annoying here. So let me go to app.js and here in app init, I'll disable this timer code here. Save that so that we don't have this in the console. So with that, let's start by making the elements here draggable. And we'll do this by going to the HTML file, to the elements here, and there on the list item, which is the element that should be draggable, we add the draggable attribute, and important, set this to true. Just adding it like this would not be enough. You have to set it to true. If you created the element programmatically, you can control the property, the draggable property, and set that to true. Of course, do that for all the list items here. So for the 2 in the first box and the 1 in the third box. And once you did that and you save the file and you reload, you can already drag this element here. Now, dropping it somewhere won't do anything. You can drop it everywhere and it will not do a single thing. And here you also see that you get this visual feedback. We have the item here, a transparent version of it on our mouse cursor, and we can drop it anywhere, but it's not really moved, and that is how it should behave. Now, side note, you see here when this is not fully visible, we get this effect where the finished projects part is also part of the element, but we will only drag the selected element. So that all will work as expected. So now this is draggable. How do we proceed? Well, the next step was to listen to the drag start event. So in app.js, we want to do that, and that happens on the item we're dragging. So we're represented here with our project item class. There, we're setting up listeners to the more info button and to the switch button. I will also set up a listener to the drag start event. And for this, I'll add a new method here and I'll name it connect drag. You can name it however you want, of course. I'll just name it like this to be in line with connect more info button and connect switch button. And then here in the constructor, I will call this connect drag like that. Now inside of connect drag, I now want to add this event listener. So here we can get our element by ID, by this ID, because we have the element ID stored in the ID property of this class. And then, as we did it earlier, add an event listener, and then here, drag start. This is the event I want to listen to. Now we get an event object in that function, and I'll just use an anonymous function here. You could, of course, also add a new method and point at that. And now in here, we can configure that drag event, as I mentioned. You can configure the data you want to append. You can configure which kind of operation it is so that the browser can display the correct cursor. And you can also, if you wanted to, change this preview image, which is generated here. So the thing attached to our mouse. By default, it's a preview of the DOM element. Now you could also point at any other image here. And by the way, in the last lecture of this module, you'll also find a more detailed document regarding drag and drop operations with alternatives and also deeper explanations on other parts or other things you could do with it, which we simply don't need in this project here. So that will be a great resource to dive deeper. In this example here, I don't want to change that preview image. I want to append some data though. I want to append the ID of the element we're dragging, so that later, when we drop it somewhere, we can extract that ID from the event object and do something with that, because otherwise we'll not know which kind of element was dragged in the place where it is dropped. We can do this here with the event object, because there, since it's a drag event, you'll have a data transfer property or object, which it is, and there you can call a set data method. Now on set data, you can set data of different types. You find this document attached. Here you find examples of the different types of data you can add. For example, you can add plain text identified with this identifier and then any text of your choice. You can attach links. You can attach HTML or XML content. So you can attach a broad variety of things, of data. And the type which we use here will be important for when we then plan on making or adding a droppable zone or place in our application, because there we could check what is getting dragged over it so that we don't accept any droppable data, but only of a specific type. So here I'll go with plain text, and therefore the first argument here is text/plain, the identifier for, well, just text. And the second argument is this ID. the ID is in the end just a string and therefore plain text, so we can't just pass the ID like that. We can also set another property on data transfer, and that's the effect allowed property. Here we describe which kind of drag and drop operation is getting performed. And this can have one of these values here. You also find this link attached, where you can have a move operation, a copy operation, and so on. Now the browser cursor should be updated accordingly. And here I'll go for a regular move operation by simply setting this equal to move here. And with that, for me, my drag event is configured. We added some data to it. Now the next step is to make a certain part of our page a drop zone, if you want to call it like that. To mark something as a drop zone, or as a place where you can finish a drag event, so to say, you need to add an event listener and prevent the default. And we do this on our project list here, because when we drag an element here, I want to be able to drop it here into this list. So we need to go to that list and listen to these events and prevent the default. For that, here in the project list class, which is in the end responsible for managing our lists, I'll add a connect droppable method and trigger that from inside the constructor, so that when we create a new project list, we in the end set up this droppable event listening here. For that, we need access to the list, and we can get access here with this selector here, or almost this selector. Remove the li here, and instead get access to the unordered list, the ul tag. And this gives us access to the list element itself. So not to the section with our items, but only to the list in there, because that is where ultimately the items should be added. So now on that list here, on that unordered list in our project list here for the two different types we have, we can add an event listener. And I'll add two event listeners, one for drag enter, where I need the event object and then we do something, and one for drag over. Now again, the difference is when they are triggered regarding nested child elements. You definitely need the drag over listener, and in there you need to call event prevent default. For drag enter, that is optional. Nonetheless, I'll do both. And now we can just call event prevent default here, just like this, and do it in both event listeners. And with that, we would be able to drop our element here, and the drop event would be triggered. If we don't do this, then we can still drop the element there, but no drop event will be triggered. Now, sometimes you might not want to always just prevent the default here if something is dragged over it, but maybe you also want to check the type, let's say. You can do this with event data transfer, and there you could check types, which is an array that exists in there, and have a look at the first element. And here I want to check if that is text plain. And if it is, then I want to prevent the default. Otherwise, I won't. And that means that if we drag anything else above this, which is not possible on this page because the only thing marked as draggable is the list item, which will set that data type when we start dragging. But if you had more drag and drop operations on your page, where you, for example, can also drag some links or anything like that, well, then you might want to add such an extra check to make sure you're only accepting the right kind of data here to be dragged into. What you can't access here as a side note is the concrete data that is attached. So you can't access the data that's attached here, only the type of the data. So we unfortunately can't read the ID, for example, in here. That is not possible. We'll have to do with the types. We will be able to then get that data in the drop event though, and that is the place where we ultimately update our UI. Before we do that, however, I also want to adjust my styling a little bit to give the user some visual feedback that you can drop something here. Because right now we could drop an item there, but we don't really see that it's possible. Now, to give the user some feedback, I'll go to drag enter here. So when we first enter this unordered list, so to say, and in there, on the list, to be precise on the parent element of the list, which is the section, I'll add a class with class list add, which should be droppable. Now this class doesn't exist yet, we have to add it. For this we can go to the app CSS file, and there, anywhere where you want, maybe below that card here, you can add a droppable class written exactly like in a JavaScript file and assign a background color of, well, I picked FFEOEC, a slight rose color. So now this will be added as a background color to the item. We drag our item over, and now if we reload, I get an error, line 155. Here in Connect Droppable, well, we should use this type here, of course, because it's in a property. It's not a variable that would be available here. And I also see that here we should, of course, change this to just query selector, not query selector all, because I'm only selecting one list here, the first and only list in here. So let's save that. And now after reloading, this works. And now if we drag this, you see this now, the background gets marked, and also if I drag it down there. Right now, this never gets unmarked, but that's something we'll add. But at least it works. So we successfully add our styles, which also proves that this event triggers. Otherwise, that wouldn't happen. To be precise, I might wanna update this style in this if check, because that is the only condition under which we should be able to drop something there. So let me reload after changing this, and it still works, which means our if check works. So that's great, this is working. Now let's make sure we also change that style again once the item leaves this box, because right now we change the background once, but then we keep the style, which of course is not what I want to do here. To make sure we update this style once we leave the list with our element, we can add another event listener to the list, and that's the drag leave event listener. And this will trigger whenever we, well, leave the list with our element. Now here we got some tricky behavior though, as you will see. But first of all, let's just start with the implementation you would probably expect. We simply remove the droppable class here whenever this triggers, because that means we, well, left the list with our item, right? So now if we implement it like this, however, we'll see that this doesn't work correctly. If I reload, it gets marked, but you see, I'm still in the list, and nonetheless, this got removed. If I re-enter it briefly, it's there, but basically as soon as my cursor moves over some child item, this style gets removed. Same for the bottom list. Here it is. As soon as the cursor is above the other list item, the background is not marked anymore. It should still be marked though, because I'm still in the droppable area. My cursor just is above a child item. And the issue is that the drag leave event also fires when we basically leave the list here because we enter a child item of the list. Now to work around that issue, I want to add a if check here and only remove that class if the leave event triggered because we really left into a non-child item. Now for that we can use event related target, which I mentioned earlier in this module. It also exists for drag leave, and it will point at the element we moved to. So when we leave the unordered list here and the cursor is now somewhere else, the somewhere else element will be the related target. Now we can check if that related target is inside of the list, in which case I don't want to remove the style, or not. And for that we can use closest again. We can use closest to select the closest unordered list with this selector up here. So with the exact same selector, and hence we need backticks here, we can check if the related target basically has an ancestor, which is this list. And if it has such an ancestor, we know we're still in the list. If we don't find such an ancestor for the related target, then we know we're outside of the list. So here I want to check if that item I'm selecting here with that, if that is not equal to the list here, so to this list, because if it's not equal, then we're not inside of the list. And in this case, I want to remove droppable. Otherwise, we'll not do anything, because otherwise we're still in the list with the item. Now with that, if we reload, we should have a behavior where we can drag this and it stays here, the background stays. Only if I leave, it gets removed, and the same for the bottom here as well. So now we can really move that item and now drop it anywhere. Now we just have to make sure that when we drop it, we also move it. Now to react to a drop, we can add another event listener. still on the list because that's the area where we drop, and that's the drop event we're listening to. Now in the drop event, we can extract any data from the event object, which we added here in drag start. So data we passed here can now be extracted in the drop event. That is available. So down here in drop, we can now get our project ID by going to event, data transfer, get data, and now your data identifier, which is text/plain. That will retrieve this data. Now here, remember, we are in one of the two lists, and I want to make sure that if we're in the other list, so if we really dragged the element into the other list, I do add it to that list. If I dragged the element, but let loose of it in the list it already was in, I of course don't want to add it there because it already is in that list, right? So since this event listener here is added to list and runs inside of a method of project list, we have to check if in the projects of that list the event listener runs on, if there we find a project with this ID. So we go through all projects and compare IDs. Now, if we find a project with that ID in the projects that are already assigned to that list, then we know we dropped it in the list it already was part of. And then I don't want to do anything. So in this case, we can simply return here, which means we don't continue with this function execution, which means the next line doesn't run and therefore we don't do anything. Alternatively, you check the opposite here and move all your code into this if statement. So now here I only continue if we're not having this project already. So if we really dropped it in the other list. Then I want to add it to this list where we dropped it, and I want to remove it from the list it came from. Now it's actually not that simple because the projects I can interact with are only the projects where the dragged project is not part of, and I only have the ID of the dragged project. So we would have to find some solution, just as we did it earlier in the course already, with some function we pass around between the two list instances, so that we now can call a function in the other list and move our element. Or we do something else. What if we then simply trigger a click on the finish button or on the activate button? That would do the trick, right? Because that will move the element. It will run all the other click listening logic we already did set up. So that's what I'll do here. I'll go to my document here and then get an element by ID and use that project ID because that is assigned as an ID to the HTML elements. And now inside of that project which we selected, I want to get access to that button, which I can get with query selector, button last of type. And then there we can call click. And now effectively what I do is I go to the element which was dropped, which isn't really moved, as I explained, just it looks like we move it. So we go to the element which is getting dragged, in this case the finish the course element, and once I drop it, this button here is clicked for us with the help of this code. This is what's happening here. Of course, I also want to remove the droppable styling here, so I'll copy that line. And what you can do here as well is you can call event prevent default. It's not required, but you can do it if there were some default behavior for dropping something here. For example, if you would be dropping some image somewhere else and the browser might then typically load that image full screen, you could omit it here or prevent that here. So you can add this. Here we don't need it though. And therefore here we're actually done. Now let's see if that works. If we save that, and we reload. If I drag finish the course in finished projects, you see the same thing happens as when I click a button here. And we can drag items around just as we should be able to do. So this is looking pretty good to me here. This is drag and drop implemented here and working like a charm, as you can tell, and therefore we get that finished. Now, before we close this module though, let me also show you the drag end event, which we don't need here, but which you also can listen to. Now, as I mentioned, you can also listen to a drag end effect, and you do that on the item where you also listen to drag start. So in this case, on the project item. There, you can basically copy that line, and of course, we could also therefore refactor that item equals this here, and then use item add event listener, and then here also item add event listener, and listen to drag end here to then do something when a drag ends. Now we can console log the event here to see what's in there and save that. And with that, if we reload and we now drag and drop, you see this is the event which gets emitted. And in there we can get a couple of pieces of information. For example, the target was the element itself. By the way, for the drop and drag enter and so on events, so for all the events we added as listeners to the list itself, the target always would be the list, never the element which is getting dragged, because it's the list which triggers the event in the end, right? Here, however, drag end is on the item, and therefore the target is the item itself. And now here we can also pass around some data if we wanted to. In data transfer, we also have the drop effect here. We allowed that move effect, and you see the drop effect now also is move here. Now that shows you that the drop succeeded. Because if a drop does not succeed, for example, if I let loose here, we still get the drag end event, but there you see data transfer drop effect is none. So you can always check the drop effect property in data transfer to find out whether a drop succeeded or not. And now you could also run any logic you want in here to, for example, update the UI or move data around. That would also be possible. And that's it. This is drag and drop implemented with this example. As I mentioned in the last lecture of this module, you'll find a complete guide also with some other examples and more details if you're interested. And with that, you learned a lot about events and specifically also about drag and drop. So we implemented drag and drop in this module, and in general, you learned a lot about events, event listeners, how you can add and remove event listeners, about the event object, how to get data out of it, and that the data you can get out of it differs based on which kind of event you're listening to. You learned about prevent default, which can be super important, and about the capturing and bubble phase, which you can control with stop propagation. You learned a lot about patterns like event delegation, which can be useful. And in general, you hopefully now have a good understanding of events, how they work, that they are important, and what you can do with them. All these examples, of course, were related to events in the browser, but the idea of listening to events, even if the syntax is a bit different, is the same in a lot of programming languages. And I did mention it earlier, I will say it again at this point. You also should later check out the Node.js module to get an idea of how that works. And there you will also see how you listen to an event or how that works in a Node.js example. And with that, we got that out of the way. Let's now move on.